Assalamu alaikum. This is Rizwana Mukhtar, lecturer, Department of Physics, Milestone College. How are you all? I hope you all are well. At this pandemic situation, as you are not able to go outside from house, so I am here to take an online class. In today's lecture, I am going to solve two creative questions from chapter 5, which is states of matter and pressure. I hope this lecture will help you to better study at home. Our first creative question is from Borishal Board 2017. Here you can see that there's a diagram of a hydraulic press machine. The diameter of the smaller piston is D1 20 cm and the diameter of larger piston D2 equals to 40 cm. And there's a sphere on the larger piston. Radius of the sphere is 5 cm and density of the sphere is 10500 kg per meter cube. Now question number C, find the mass of the sphere. So let's start to solve the question. C number. Here the given informations are radius of the sphere 5 cm. Radius of sphere r equals to 5 cm. Now as it is in CGS unit, so we have to convert it into SI unit, that means 5 divided by 100, that is 0.05 meter. Now the density of a sphere is 10500. Density of a sphere rho equals to 10500 kg per meter cube. And we have to identify the mass, that means mass of the sphere. Mass of sphere m equals to what? Now before calculating the mass, we need to calculate the volume of the sphere, because we know the formula to identify the mass, m equals to rho v. So we know rho equals to m by v, that means m equals to rho v. Now here the volume will be volume of sphere v equals to 4 by 3 pi r cube. Now v equals to 4 by 3 into the value of pi 3.14 into value of r 0.05 whole cube. So after calculating it, you will get the answer 5.23 into 10 to the power minus 4 meter cube. Now we know the volume of the sphere and density as well. So we can calculate the mass of that sphere very easily. Rho 10500 into 5.23 into 10 to the power minus 4. After calculating it, you will get the answer, that is value of m equals to 5.5 kg. And this is the answer of question number C. Now question number D. If 15 Newton force is applied in the small piston then is it possible to raise up the sphere or not? That means we have to calculate the weight of the sphere and the upward force that is exerted on the larger piston. Then we can say if the weight of the sphere is greater than the upward force, then the sphere will go downward, and if the weight of the sphere will be smaller than the upward force, then we can able to raise up the sphere. So start to calculate question number D. Now here given informations are, you can see that the diameter of smaller piston is 20 centimeter. Diameter of small piston D1 equals to 20 centimeter. That means 0.2 meter. Now diameter of large piston D2 equals to, here you can see that 40 centimeter. 40 centimeter. That means 0.4 meter. Now the force that is exerted on small piston, that is force on small piston F1 equals to 15 Newton. Now we have to calculate the force on large piston. F2 equals to what? Now we know the formula to identify the force which is felt on the larger piston is F2 by F1 equals to D2 square by D1 square. Now F2 equals to D2 square by D1 square into F1. Now we are going to put the value which we know. The value of D2 is 0.4. The value of D1 is 0.2. We can write that it's the whole square. Now the value of F1 is 15 Newton. So after calculating it, you will get the value of F2 equals to 59.96 Newton. Now we have to calculate the weight of that sphere. That means weight of sphere W equals to mg, and from the question number C we get the value of m equals to 5.5 kg, and the value of g we know that 9.8 meter per second square. So 5.5 into 9.8, then answer 53.9 Newton. So now as you can see that the upward force F2 is greater than the weight of the object. That means F2 is greater than W. That means the sphere will rise up. Now our next question is from Rajshahi Board 2019. Here you can see that the given informations are area of small piston A1 equals to 0.09 meter square. Force of a small piston is 500 Newton and the area of larger piston A2 equals to 2.7 meter square. Now our question number C is find the value of F2. That means we have to find out the upward force that is felt on larger piston. So here the given informations are area of small piston A1 equals to 0.09 meter square and force on a small piston F1 is given here 500 Newton. Now the area of large piston A2. Here the area of large piston is 2.7 meter square. Now we have to calculate the value of F2. That means force on large piston. F2 equals to what? Now you know the equation to calculate the upward force on a piston is F1 by F2 equals to A1 by A2. Now we can write that F2 equals to A2 by A1 into F1. Now I am going to put the values. Here the value of A2 is 2.7, A1 0.09 into F1 means 500 Newton. So after calculating it, you will get the result 15 into 10 to the power 3 Newton. Now question number D is there any change of work done in the both piston mentioned in the stem? Explain mathematically. That means we have to calculate the work done of piston A. Here you can see that the displacement for the piston A is given 5 cm. So firstly we have to calculate the displacement of larger piston. And as you see that here the liquid is fixed, that means the liquid is incompressed here, so that we can say that the volume of liquid that is in the smaller piston is equal to the volume of liquid of the larger piston. So now we are going to start the calculation of question D. So here the given informations are force on a small piston F1 equals to 500 100 Newton. Now the displacement of small piston is given here 5 centimeter. Displacement of small piston L1 equals to 5 centimeter. That means 0.05 meter. You know that to convert centimeter to meter we have to divide 5 by 100. Now force on large piston the value of force on large piston we get from the question number C, that is 15 into 10 to the power 3 Newton. So now firstly we have to identify the displacement of large piston, then we can identify the work done in both pistons. That means we have to calculate the displacement of large piston. L2 equals to what? Now here you can see that the liquid which is filled in that machine is compressed. That means the volume of the small piston or the volume of the liquid that is on the small piston will be equal to the volume of liquid of larger piston. So we can write that A1 L1 equals to A2 L2. That means L2 equals to A1 by A2 into L1. Now I am putting the given informations here. Here you can see the value of A1 is 0.09, value of A2 is 2.7 and the value of L1 is 0.05. After calculating it, you will get the value of L2 is 1.67 into 10 inverse 3 meter. That the formula to identify work done is W equals to Fs. Here S means displacement and we are taking L1 as the displacement of smaller piston. So we write the formula as W1 equals to F1 L1. Now the value of F1 is 500 and L1 is 0.05. After calculating it, you will get the answer 25 joule. Now work done by large piston. Work done by large piston, that is W2 equals to F2 L2. Now as the value of F2 is 15 into 10 to the power 3 and value of L2 is 1.67 into 10 inverse 3. So after calculating it, you will get the answer W2 is also 25 joule. So we can say that the work done by the both piston is equal. That means W1 equals to W2.